This is our first stage of our project PPT, and we are moving on to the abstract. Flight delays pose a significant challenge for the aviation industry, resulting in substantial financial implications each year. Prior studies have explored machine learning approaches to predict flight delays. This study proposes a novel deep learning model utilization support vector machine for flight delay prediction. DL is a state of the art technique capable of handling complex problems with large datasets and automatically extracting essential features to address the presence of noisy flight delay data. A stack denoising autoencoder technique is incorporated into the proposed model. Moving on to the introduction, a flight delay occurs when an airline's departure or arrival time exceeds its scheduled time by more than 15 minutes. Causes of delays include adverse weather conditions, aircraft congestion, late arriving aircraft from previous flight maintenance issues, and security concerns. This comprehensive approach not only addresses customer concerns but also helps airlines avoid operational challenges and maintain a positive reputation. Flight delays have wider ranging negative impacts, including economic losses for commuters, airlines, and airport authorities. Now we are moving on to the literature survey based paper 1 in the year of 2021. Delay propagation evaluation of flight chain model based on big data visual analytics. They have authors and on the ideas of the paper. Literature survey based paper 2 in the year of 2019. Predicting flight delays with artificial neural networks case study of an airport. They have given the authors and the idea of the paper. Moving on to the literature survey based paper 3 in the year of 2020. Modeling flight delay propagation in airport and airspace network with the author and the idea of the paper is given. Moving on to the existing system, prediction model and algorithm of flight delay propagation based on the integrated consideration of critical flight resources. A model for predicting flight delay and delay propagation based on parallel cellular automata. Disadvantages: it is very difficult to accurately predict flight delays. The probability of delay can be predicted when delays are less than 2 hours. The effect of delay regression analysis is not satisfactory, and we have a proposed system for this project. This proposed system helps airline passengers to know whether the flight will get delayed or not. Supervised learning, as the name indicates, a presence of supervisor as teacher. It was useful to have labels that state if this flight's arrival or departure was delayed. We can use it to predict if a flight carrier will be departure a delay and hence try to avoid that from happening. This project have some advantages that accurately predict delays, improve flight planning, and prevent delay propagation. It can provide decision basis for airport authorities, the flight delay early warning and emergency decision support system. This model fully exploits temporal and spatial characteristics of higher dimensions. Forecasting for robust airport operations optimizations. Then we have a system architecture that starts from data driven from flight delay and splits up into admin and flight agent. In admin, they have moves up two types: weather data pre-processing, future extraction, classification (SPM), and in flight schedule, it has a FDDB and predictor. In flight agent model, it has update new arrival time, FD information announcement to passengers, and receive the alert. And we have some modules that flight delay web U1, pre-processing datasets, data collections, data splitting, and future extractions. We have used a support vector machine. The result shows that the prediction performance of the model is much better than the other two. The model can effectively predict flight delay. Random forest was the best classifier with an accuracy of 77%. Established an improved support vector machine model to predict flight departure delay. And we have a gradient boosting classifier algorithm. Is another tree-based method which is used to improve the problem of overfitting decision trees. We have a testing phase. The parameters of the network are weights and biases of each layer. Back propagation along loss function is used to learn the network parameters. We have a performance analysis. In that, precision recall are there. In precision, the ratio between the two positives and all the positives in our model, it is measured of flights that we correctly identify having a delay out of all the flights actually having it. In the recall, the measure of our model correctly identifying true positives. We have a specificity and accuracy. In specificity, the proportion of actual negatives which got predicted as a negative or true negative. In accuracy is a statistical measure which is defined as a quotient of correct predictions and the true negative made by a classifier divided by the sum of all predictions made by the classifier, including false positives and false negatives. And if moving on to the result, we would like to describe our result and discuss about a result in following manner. In the initial phases, we perform data exploration, future engineering, and test splitting. So when comparing the training time and accuracy, gradient descent is the best performing algorithm for the dataset to be used. And we have included the reference that we have taken. We have 10 references that we have seen. And we have a conclusion in this project. We were able to successfully apply machine learning algorithms to predict flight arrival delay and show simple classifier like decision tree and logistic regression can predict if a flight's arrival will be delayed or not fairly accurately. Apart from the financial losses incurred by the industry, flight delay also portray a negative reputation of the airlines and decreases their reliability. And moving on to the publication journal, we have put in a publication 14th ICRT conference 2023 European Chemical Bulletin. And moving on to our journal paper, these are all the journal papers of our project. And we have acceptance letter for our project publications and conference to be attended on June 9th. Thank you for your cooperation, and we are moving on to the implementation.
Now we are going to see the output of the machine learning based flight delay predictor. First we log in username as admin and enter password. We have to log in first. In training session we have a data exploration. First we have to see airlines. There are n number of airlines in there. So we have to assign each airlines has unique code. Okay. Similarly, there are n number of airports, so we have to assign a unique code for that airport cities and state and different types of latitude and longitude. Similarly, the flight. These are called as datas. Then click pre-processing. Pre-processing is nothing but data processing in machine learning refer to the technique of preparing the raw data to make it suitable for a building and training. In simple words, that transform raw data into an understandable and readable. Okay. Next, identifying null values in dataset. This is nothing but a field with a null value is a field with no value. In a field in a table is optional. It is possible to insert a new record or update a record without adding a value to this field. Okay. This field will be saved with a new null value. Then feature extraction. In features extraction, they have a bar diagram, a travel frequency with month wise, in day order, in monthly wise, in weekly wise. These are the chart graph method. Then classification. This is our accuracy level. Okay, 90, 99.84. This one. Precision achieved 99.82. Then recall achieved as 99.73%. These are our accuracy levels. Then we have to log out this page. Then we have to go for testing phase. First we enter a flight number. We have to copy any of this flight number. Then origin of the airport. Then destination airport. Then which date you want to predict the airlines. Select that date. I select 31 first, the next day of this day. Then click submit. This is our output of uh, this flight delay model. The scheduled time of airlines is 2:30. Arrival time is 2.27. The delay time is 3 minutes. This is our output. Okay. Thank you.